Hi, I'm Alan Ross, one of the Blues Brothers, and with me today is Dominic Musisca, and we welcome you to another edition of Take Five. Dom is a Take Five fiver special. He's been on before and will be again, and has got a great deal of knowledge. But we just decided today that we wanted to have a bit of fun, and if we could play I'm a Soul Man, we would be playing it. Dom, welcome to this edition of Take Five. So let's get serious for a moment.
Okay.
Thank you for the glasses, and thank you, Debbie Carty, for making sure that we have our Soul Man glasses. Only you and I will know this. The next time we're live together, we're putting the glasses on and people are going, what are you two doing? And if you could you possibly do a backflip for me like John Belushi did in the movie? Just if you could.
I have some room. May not turn out really well, but it'll be entertaining.
Okay, it'll be entertaining. So Dom, you know, for a good number of years now, you've served as the industrial and commercial markets at SDMyers. You're a senior transformer specialist, and that means you see a lot of problems that come across your desk, usually with testing problems, or you get calls from your customers who are saying, hey, that thing I told you about, it happened. So you have a lot of problems there. So here's what I want to do. You see a lot of problems after the fact. So you see the problems before, which I think we addressed in your previous Take Five, and we talked about moisture and doing some maintenance, particularly the oil. But now I want to talk about the problems you see after the fact that could have either caused a shutdown or could have caused a shutdown. And two of the biggest reasons we know that transformers fail is load tap changers that fail, or bushings that fail, particularly bushings. I think bushings is now #1, and I think LTCs is #2. So what have you seen as more of the significant maintenance repair issues as it relates to bushings or LTCs, and as these problems, as critical components of transformer, as these play out in the marketplace? What problems do you see, and how do you overcome them?
Well, Alan, I absolutely see a wide range of issues that have caused transformers to fail on both of those. In fact, just last week, I was out in Western Pennsylvania at a substation where a customer contacted me, and they had a bushing fail. Wasn't anything real drastic or anything too exotic. It was basically just a raccoon actually had gotten on top of the transformer and shorted out the bushing.
And so, shorted out the raccoon.
Shorted out the raccoon, yeah. He went up in the pearly gates with his wings, but unfortunately, it caused the failure of that transformer. And the co-op that I was dealing with had to come out in the middle of the night. They found the raccoon. They were able to switch the load over to get power restored back to their customers, and then came out several next 2 days later and went ahead and de-energized that transformer completely, grounded it out, took off the leads, and then proceeded to get information for us, contacted us, and wants us to find them a bushing, which, as you know, finding parts for older transformers is like finding parts for an Edsel. You might as well call up the guys that wander around in the vans across the country and have them look for parts. So
that brings up an interesting question, because I know there is an older transformer company that you can buy or rent older transformers that fit a footprint, right? And there are people that have cannibalized them. They're like junk shops for transformers, where they do take the old bushings and they have them. And there is out in the marketplace, there are some people that do that, but it is a very rare find to find a perfect match. So what do you do when you find that and you got to get a new bushing?
Well, as anything, I gather as much information as possible. You know, if we're lucky, we can find bushing nameplates actually located at the bottom of the bushings, and that gives us the serial number or the actual part number of that bushing, which is fantastic. Yeah. Unfortunately, sometimes those bushing don't have the nameplates, and we have to do it the old-fashioned way with taking dimensions, counting how many cooling sections there are on the radiator. If they're brown bushings, you know they're very old, post 1950s. But if they have the nameplate, it's fairly easy to find. we turn that information over to our service manager and our quoting department, and they're able to contact 4 or 5 different companies, which gets us information and parts and the lead time on those parts. So,
and it's usually a long time.
it is, unfortunately, yeah. Once again, the older the transformer, longer the lead time. If it's a newer transformer, you can get them relatively easy.
So the bypass systems or the workaround systems are unique. Maybe it's a little bit easier for a co-op because they can route power, but when you're an industrial plant and it's a furnace transformer, you're not going to have a workaround. That line's going to be down. If you're a data center and you're running off of generator, you're going to run off of that generator and you're going to be eating up a lot of diesel fuel or whatever fuel. And it's not the same quality of power, so you create all kinds of separate problems. You spoke of the brown bushing. I want to stay there for a minute because I have a friend, one of our EPRA fellows, who can look at a bushing and look at the color of the bushing and tell you how close it is to failure, because that browning is overheating. It has caused the ceramic to change color and overheat, and he can see which of 3 bushings is going to fail by the color of the bushings. So the brown bushing is something that every one of our EPRA members ought to say, hey, go out there, Larry, and check and see if we have any brown bushings, because that's one that's going to give you a signal. Simple visual signal, which is the cheapest way to do it. So let's switch gears a little bit and let's go to load tap changers, LTCs. I know they're not as common in the industrial or commercial world, but where they are incredibly critical. Talk to me a little bit about what you've seen with LTCs and why maintenance on them and what can go wrong.
Well, with your LTC compartments, a lot of understanding is really lost with the individuals knowing that a maintenance performed perhaps every 4 or 5 years is a good idea. A lot of people think that the LTCs can just go along and be operated continuously, switching voltages over, especially in foundries and steel companies. I've seen that a number of times where the power been in a substation with one of our business development guys, and we actually heard the transformer energize when the rod in the steel mill was actually being arced over. The sound exaggerated and actually scared all 4 of us. Our contacts, but the constant activation and the atmosphere that those LTCs are working in really do need to be inspected and checked out. Too many times I've had customers contact me and they've already had issues noticing on their control panels where they're not getting the power that they needed at critical times and critical peaks. So having those temporary shutdowns, remove them. I've talked to our field crews and repair members many times where they've gone and did an inspection on an LTC, and when they opened up the door after they've drained it, they actually seen parts laying on the bottom of the LTC.
I've seen that too. We had a whole box of them, and we shocked the customer when we said, hey, we found these, and these are the contacts from your LTC, and we found these laying on the floor. Some of them were so corroded, they were so badly damaged, and many of them were, you know, one action away from that whole transformer failing. But we've seen them too, the contacts. So you're saying every 4 or 5 years, is there usually a manufacturer says, hey, a certain number? Yeah, go ahead.
Yeah, there's an OEM. You should we always refer back to the OEM. The manufacturer has all that specific designs for inspections and testing of the units. But typically those, before it was 5 to 7 years. Now we're hearing 4 to 5 years. And typically when the transformer fails, you know, you have a couple different options. Obviously, after the transformer is drained down and the LTC compartment's drained down, and you do an inspection, depending on the damage inside, you can either do parts repairable or you can actually do a retrofit kit to where the actual LTC can be pulled out and replaced. Cost is about the same. There might be a few $1,000s difference between, but where you really save money is time versus taking that whole LTC apart piece by piece inspection versus having a retrofit kit which you can take out, put in. You're still looking at a 2-3 day shutdown for it, but you're still having much more efficient repair on it because you have less items that you have to account for individually.
Excellent, great tip. And those repair kits, I assume, are available on the market. I know SDMyers can have access to them, but how else do our members find that?
Actually,
Who else?
and a lot of times you can contact, the OEM, and they can give you directions on where you can get repair kits from,
Right.
and information on those.
Okay. And I know that Rheinhausen has opened up a lot of shops in the U.S. and been able to do that. And it is such a common LTC out there that they could also give direction to it. We try to be company agnostic at EPRA. We want to make sure that we spread the wealth there. But thank you. This has been another great Take 5. So with that, the Blues Brothers would like to thank you all for listening to this Take 5 from EPRA. And the next time the Blues Brothers come on, we're going to have music. So thank you so much, Dom. I appreciate you. We'll see you next time.